Server 2016的那些 new feature 啊，我呢觉得这个话题呢非常的有兴趣啊，很多的我们的那个 community 的 members register this event. So, all right, let's kick this off. 8月份呢，离那个确实又很近了，就是 Pass Summit。那么今年是在 Seattle， 我相信如果大家去呢，我是去的，然后我知道 James 也是去的。那么有机会呢，我们可以像以往常一样，我们每年都在那边呢，可以认识很多新朋友，也是老的朋友呢见面的一次机会啊。如果你还没有 register， 没有 register 呢，你可以用下面这个discount code 可以 save 150块钱去 register 这个 event 啊，可以 register 这个 event。它的时间呢是 October 27啊，我相信过会儿 Lindsay 讲的时候，估计他们的一些 SQL Server 的 team， 因为在 Seattle 他们有很多的同事也可以来，所以呢我们有很多东西可以请教他们啊，这是一个很好的机会 SQL Pass 的Summit 的2015。这一页呢是一些 virtual chapter。那么我们呢，如果你今天新来的，我相信大家都是不是新来的啊，我们是 one of the community virtual chapter SQL Pass 这个 logo 呢有可能要改。上次有个人联系过我，他们想把那个图案全部去掉然后呢，如果是意大利或者 Hebrew， 你看就像这个 Hebrew， 它用一个 Hebrew 的文字来表达，我不知道这个什么意思。我不知道，大概是 SQL Pass 的意思，所以呢，他也不希望看就是大家统一把一个中文去表达一个 SQL Pass 这样一个东西，所以 logo 可能要改。All right， 那么大家肯定一定听说过，或者有人不知道啊 ，SQL Saturday。那 SQL Saturday 呢是一个 one day 的一个 free training 的一个 opportunity， 在美国几乎每个州的每一个大城市都有啊，甚至有些州都是2-3个城市啊。像我这边的话达拉斯San Antonio Houston Austin 都有啊。那如果大家在达拉斯的话呢，做一下广告，达拉斯呢会有一个 BI Edition， 马上就会有，而且呢是我想不起来日期了，9月5号，如果我没记错，不是9月5号就9月8号，我们会有个 BI Edition 的一个 Power BI 的一个 road show 啊，非常的不错啊，非常不错。那么 Power BI 大家也知道，顺便提一下 Power BI。大家都知道大概一个月前它这个版本 release 这个版本 release， 所以呢有很多新的东西需要我们 catch up。那么达拉斯这个地方呢就是9月8号还是9月5号吧，是那个 road show Power BI 的一个 road show。如果大家有兴趣呢是晚上的5点到9点8点忘了，大家可以来看看非常有趣的一个 event。然后你可以关注一下你 local 的一些 event， 我觉得呢 local 也有的达拉斯也有，我相信其他地方也有的那么比方说Oklahoma City， 我不知道这边有没有人来自 Oklahoma。我还第一次看到这个 El Paso。那如果这个是 Dallas 的这个是 Texas 的 El Paso 呢，那 Texas 就有5个城市有那个 SQL Saturday所以呢你可以 check out 下一个这边的一个网站 SQLSaturday.com你会发现它网站重新做过了，所以你可以找到你附近的一个城市，你看看 local 的 chapter， 看看他们 local chapter 的一些 events。 All right， 这个是关于SQL Saturday。 那么今天呢我想节点时间，所以我们没有放很多东西在上面。那么我们呢有一个 group， 我们放在那个 LinkedIn 上，如果大家有兴趣呢 keep posted。 我基本上呢一个是给大家发 email， 第二个呢是我会把一些 announcement 或者一些 updates 放到那个 LinkedIn 的 group 上去。 All right， 那么在我交给那个我们今天的 speaker 之前呢今天的话题呢是 SQL Server 2016的一个 new features。那么因为我自己呢上次在那个 local 的 event 呢我听了一遍，我觉得那个人讲的也很好，当然我相信今天我有更多的期待，因为 Lindsay 这下面是这个今天 speaker 的一个简介。那么他呢在微软工作了20年，那么又是以前呢是那个 Azure Data Customer Advisory Team 的 Architect and Manager. Right now she is the Principal Group Program Manager of the SQL Server Code Engine. So with that, I just switch to today's speaker, Lindsay. All right. Oops. Okay. Right, Lindsay， 我把你的麦克风打开了，然后你现在是 对 ，OK。
Okay, can you see? But what happened to 这边这个要不要把这个关掉？
哪个关掉？
Can you see the sidebar? Should I close it?
I think if you hit how many monitors you have?
Just one.
Just one. Okay.
It's not working.
Yeah. Probably you can if you just one. Why you have this slider one? Yeah. I think if you hit F5, what happens?
Not sure. Hold on.
Uh-huh.
Yeah, still there. Should I close it?
It close it. That's good. Right now it's good.
No, but it'll ask me to leave the session if I close it.
I
cannot minimize it.
OK。哦，你说那个 panel 对吧 ？OK， 我搞错了。那个 panel 是这样的，在左侧，就这个 panel 最左侧有一个橘红色的小箭头，你点一下这个小箭头，它可以缩到右侧去的。
All right. Okay. We'll stay this way.
OK。
好。Okay, let me start then.
Cool.
Thanks, Derek. 大家好，晚上好。Thanks for spending the time. I'm Lindsay Allen. I'm the Principal Group Program Manager at SQL Server and Core Engine. I'm responsible for the SQL Server Engine, storage relational engine, and also responsible for SQL Server 2016 release. So I think we have about 50 minutes. I will go through the content as much as I can and show you some demos. It's not a thorough overview, of course, right, of not one to advance. The SQL 2016, it's a highlight. So here's how we think about the release. And as our investment, we group it in the three pillars, three areas. And because there's lots of capabilities and new features in the next release, 2016. So we group them in these three areas. Mission critical performance and the platform, that's where you see all the innovations around performance, security, availability. And the second pillar is the, we call it a deeper insight across data. That's the big data related analytics investments we have. Then the last but not least is hyperscale cloud. I'm going to highlight, call out a couple of innovations which is very unique, and no other vendors in the industry have the similar capability, because we have the same engine running in the box you can install on the server, and also exact same engine actually deployed in Azure in the public cloud. So let me start with the first one. So that's basically how the talk tonight is structured. I will go through these three bucket areas to call out highlights in each area. So in the mission critical performance, and what I want to call out is our continued innovation in the in-memory engine in the server. And there's, I don't know if how many of you are aware, but with SQL Pass for a while, you probably know we have two integrated in-memory technology as a part of a SQL Server. It's completely integrated. One is the in-memory OLTP, codenamed Hackathon, and this is the new lock-free optimistic concurrency engine. And the second in-memory technology we have since SQL Server 2012 is in-memory data warehouse. This is a columnar store technology we have, and both of these in-memory technology are integrated with the traditional engine. So you'll see everything as T-SQL syntax, usability, manageability, they're all the same. I'll give a quick overview of in-memory OLTP, and because in the past 6 months, by talking to the customers, I came to realize actually this actually is not well known. majority of the folks I talked to actually doesn't know what in-memory OLTP is. So this is fairly simple slides. It's built slides. I'm talking about the four the architecture pillars of the memory OLTP. And we started on this investment 5-6 years ago with Microsoft Research, and to actually address the hardware trend of the CPU clock speed has stalled, number of cores going up, but per instruction is not doing any more work. And because you only can actually get the clock speed to go as far as like about 3 gigahertz, any faster, it could cause core melt, right? But in the same time, the main memory price, the DIMM price, has been going down, steadily going down, and the density is going up. So you can see across the industry, and everybody is starting to heavily invest in memory. So this is our offering, first releasing in production in SQL Server 2014. So at the core engine part is a high-performance data operation, main memory optimized. Your object, tables, and any other object can be main memory optimized, right? Since the table is completely resident in the physical memory, and there's no need for buffer pool or B tree, and we provide complete transactional consistency and of all your transactions. And so we do provide checkpoint and logging, but it's through a more optimized stream-based storage interface. So we log a lot less compared to the traditional disk-based and disk-based structure, the B tree. And since everything is in memory, we don't need to read off from I/O into buffer pool anymore. Reduced a huge amount of code doing I/O optimization. And the second pillar is provide you with more efficient business logic processing. How that works is you can actually have natively compiled T-SQL code. So there's a T-SQL compiler and works with the optimizer at the compile time, basically at the creation time of your store procedure to the native, will compile to native code. So there's no more interaction during the runtime, right, to generate a query plan. And since we know the code paths and during compile time, we're doing fairly more aggressive optimization of the query plan. So I mentioned a little bit earlier, this whole architecture is to support high concurrency and via optimistic locking, concurrency control. So there's no locking, there's no latch, no lock, there's no more lock manager in this case. And since it's completely main memory residence, everything is versioned. So without, you're probably familiar if you're using SQL Server. With the SQL Server and any other RDBMS product, right? In order to guarantee the data integrity and transaction consistency, there's always a synchronization object to guard the memory page or the disk page access. So with this this new optimistic concurrency implementation, there's no latch or locking, so you should not experience blocking anymore when you have high concurrency workload. So the last pillar is because it's integrated. We made a strategic decision to integrate in-memory OLTP into part of the core engine. And so you will see you can just use your regular database and you can create a memory object within the same database. And the integration will give you the same manageability experience and the features you can enjoy with the traditional engine. And HA always on, backup restore work just at the same as before. Yeah, we don't know if, because this is one of the reasons it's not as visible to the lots of customers. And in 2014, we actually support up to 256 gigabytes. You can go higher because it's soft limit, but that's as far as we tested. We feel comfortable to support. And with 2016, we re-implemented the engine to be more scalable and have better performance. So in 2016, we'll support up to 2 terabytes of user data rows within memory OLTP. So it sounds like this is one way. I don't know if there's ways to for you to ask questions. I assume there's a way to ask questions. Send it to Derek, and feel free to email me, or maybe Derek can interrupt if any of these points or slides is unclear.
Yeah, sure. So they have the chance to key in the question. We have the dashboard panel, and I will hand over the question to you once you have finished the slides. So we have a Q&A time. Yeah.
Oh, okay. I'm not sure. Okay, I'll try to leave some time for QA. I'll try my best. Thank you.
Thank you.
Okay. So then the second part of the memory technologies in memory data warehouse. And as I mentioned earlier, we shipped it since SQL Server 2012. And what changed in 2016? And what changed in 2016 is we make the non-clustered column store index updatable. So before you have non-clustered column store index, but that's read-only, right? It cannot update. And then clustered column store index is updatable. And so when you actually start designing a schema from logical to physical, you have to consciously make decision to design for data warehouse or design for OLTP. And there's always these gray areas. For every transactional database, there generally will have one or two of time-sensitive query you do want to run directly on top of the operational store. So that workload actually is termed by Gartner as HTAP, hybrid transactional and analytical processing. Traditionally, we've been talking about OLTP OLAP for past 20, 30 years. And in real life, it's the most large database are these hybrid ones. So now there's a new name called HTAP, and there will be new Magic Quadrant coming out from Gartner. And we also support the column store index on top of in-memory OLTP now in 2016. So combine the first two bullet points, we're actually supporting the new HTAP workload. We actually call it operational analytics. This way, we can provide real-time analytics on your data as your data being inserted into transactional store. It is not meant for data warehouse, but definitely meant for better analytics query real-time without minimize the impact on your transactional workload. We're doing that through the integrated column store with updatable NCCI. So the other 4 bullet points on this list is we did lots of work to improve the performance. And by doing that, this highlights the key parts of performance improvement. We added all the batch mode. And for the windowing function, we enabled that working with column store. And we improved the parallelism, and we did lots of work on aggregates pushdowns, from relational engine to storage engine. And even further, we leverage the new Intel processors vector instructions, and we push non-string filter predicates down to the CPU. So for some of these query, and you will see 10 times or even potentially 100 times performance improvement because of this batch mode and aggressive pushdown down to CPU level. And then we support the B-tree index on CCI now, so you can have the referential integrity, declarative referential integrity with your cluster column store. And now the column store works on readable secondary with always on. So you can actually offload some of your analytics query to the secondary now if you want to use column store. And the data compression, this is similar to 2014. And with archival mode, you have more compression. And even without archival mode, you should see about 10 times compression with your data. And we did lots of work with the tuple mover from the row store, the delta groups, move to compress the column segments. And with the supporting of partition level statistics, and you have a better cardinality estimation with the new CE. So this is like a scenario, right? For the operational analytics, and I know it's a new term, so we have this diagram to show the audience. For example, this scenario is like fraud detection, and it's very real. I know it's credit card companies doing this, and so you want to protect your transaction workload, right? Because you want these financial transaction comes through. And meanwhile, all the fraud detection type of query are analytics queries because they do scans, right? Do scans aggregation to find pattern. And if you don't want any performance impact on your transactional database, the typical topology is to replicate that data somewhere else, to data marts, to a data warehouse. So you can run your analytics queries. The ETL itself, and even super optimized, is still going to take about 10-15 minutes. And in common case, it takes almost 24 hours, so I take hours. And not only the data latency, and you have duplicated data all over the place, hard to manage. And with operational analytics, what we introduce here is to take the headache of latent data or stale data out of the equation. So we merge the column store and row store together into one database. So you don't have to do ETL anymore, for at least not for data warehouse, but for some of these time-sensitive analytics queries, they can run together because we did optimization to minimize any impact to your transactional workload. So let me show you. Oh, I have one more thing to show you. I'll show you a demo. One more thing to talk about. So I have a demo to show, how can you see that works, right? It's completely transparent. On the security front, we're introducing this new always encrypted feature. We'll be the first to market in the database to actually taking the man in the middle attack out of the equation. So just to say your data is stored in public cloud or in any hosters, in some hosters data center, and the staff operating that data center is not a part of your employee, right? And so you need to store some sensitive data. In the slides, you'll see Social Security number, as example, is a part of this patient's table. Need to be stored in the database, but you don't really want the network operator, the database DBO administrator see it. So it's always encrypted. You can encrypt the Social Security number to ciphertext, and you do not need to give the key to the server side. So
Lacy， 我们现在听你的声音有点问题。 Hey, Lindsay.大家稍等。
You trust your application.
Finally.
Can you hear me?
Yeah, right now it's good. Right now it's good. We almost lost you 2 minutes. We cannot hear anything.
Oh, okay, I'll go back. Okay, I'll start here. So always encrypted is a homomorphic encryption technology and will be able to query and compute unencrypted data. So for example, your data is hosted in a third-party data center or public cloud, and you don't really want some super sensitive data being accessed by the system administrators, right, of the data center. And also when data transmitted from the data center to your application will go through a wire, right? It will go through network. And all these, there could be man-in-the-middle attack. So with always encrypted, the data will stay encrypted all the time and it will stay as ciphertext on the server, on the wire, and only get decrypted on the client side. Assume you trust your client, right? And since we can do computation, this is very different for you to encrypting your column or your data with a crypto API and store as blobs, right? This was stored as blobs on the server, but we can do computation, so you will not get everything back. So let's say you encrypted the data, and with a master key only you have on the trusted side, we call the client application side. And when you actually issue a query, in this simple query here, select name from patients where social security number equal to those 198, blah, blah, blah. And when the query gets issued, and what happens is on the client side, the ADO.NET driver have a cache of your master key will encrypt the social security number, which we know is already being encrypted on the server side. And the social security number will be ciphertext, even in the parameter, and come over to the server side, and we'll do the computation. We'll actually do a seek query without scanning the entire thing, right? You see that social security number actually is on the predicates. And we'll find the row and return the results back to the application. And if the patient name happens to be encrypted as well, the ciphertext of the name will be returned, and the ADO.NET library will decrypt it before you process your row results. So let me try to show you how this, how do I get out of this? Oh, there we go. Okay, let me go to, can you see the screen?
Yes, your local host. Yes.
Awesome. So in my demo machine, I have this demo application running, right? The simulator is fairly real. I have Fabricom online pharmacy, and their chief pharmacist have this dashboard, right? Very simple dashboard, monitoring the prescription activities, inquiries, what have you, right? And this is the transaction per transaction, you know, so that's display activity per second, and for every single transaction, you log it. So this is pretty straightforward, right? But what the trick is here, and the negative sentiment actually is aggregated average sentiment response time, response of, of the sentiment table, which is the aggregation query actually. And so now we're actually able to run this in the same database without separating them, right? Since I'm remote into the machine, I cannot show you the spec because I need injecting into a fraud. Just to say now this patient's negative sentiment went up, right? You can see this real time. Let me do it, whatever. I will add the negative thing anyway. Let's see if I can get it going. Sorry. Where did it go? There we go. Okay. See, you see it spikes up now.
Right.
So now chief pharmacist goes, oh my goodness, something went wrong, right? Let's drill down, see what happens, right? So then he looks at his dashboard, drill down on the analytics. These aggregation queries look like something is not going right in the West region, and there's around 3,000 to something patients probably is in trouble. Maybe there's some bad batch of pharmaceuticals in the supply chain, right? This is Fabricam is a global company, you know, they buy things everywhere. So click on it to drill down, and if you can see on top, Terry coding their fraud investigator, Mark Harrington, because Terry, as the chief pharmacist, actually doesn't have permission to see all the patient's detail. So the fraud investigator actually have authority or permission to see the patient's detailed information, right? Mm-hmm. So let me show you first the analytics query part. So this is what's actually simple query to do in past an hour, right? And count sentiment. Count is aggregation, right? As unfavorable in that in sentiment table, and group by the region. And really simple thing. What's different is I will show you the query plan. See, it shows the unfavorable in West region spikes up, right, in the past hour. And you can see there's nothing you need to do here, and the query optimizer will use the query column store by default. Mm-hmm. And doing the hash match. So you do get a parallel gathering. So in this case, you know the query is not actually touching your row store, so not affecting the transactions. And on the query side, for the security, right, you can see now the Mark Harrington have permission. He see the patient's data here, social security number. And this actually is encrypted on the server side. Okay. Even he sees clear text. Let me close this one. Show you this is the patient claim data, has a social security number in there, right, from customer table. Mm-hmm. You see the social security number actually is encrypted, displayed as clear text on the screen here. Mm-hmm. And you drill down, you can see more patient's information. I will show you here. Sorry about I should have this in there before. I did the trace before, so I'm just collecting the trace so I don't have to show you. With if you trace, you run a server trace, mm-hmm. you will see the social security number is encrypted as a ciphertext, 64-bit blobs. So only the client that have the ADO.NET driver and the encryption keys actually can see it. Okay. So that's my little demo here. Oh. So right now, in order to encrypt, you have to encrypt in the client, right? So only way to do it at this moment by CTP2 is you can use SSS package to run through a data load process. But we're working on a tool to make that easier for you to encrypt your data. Especially when your data is encrypted, you need to rotate the keys, right? Mm-hmm. You cannot use the same key and somebody might brute force it. Right, I'll go back to my slides. Okay. So there's a popular demand from DBAs and our customers are these query performance tools. Because the largest percentage of our support case actually related to query plans. Query optimizer is very clever, but sometimes it guesses wrong, right? You get wrong cardinality estimations, and then you get a nested loop on this billion row drawing. Then that's that. The query never going to finish. And so we added the two features. Will make DBA's life a lot easier. Query store allow you to capture all the query plans as long as fits in the size of the query store you specified. And you can force the plan. If the plan gone bad, you can pick a good plan. And then second feature is live query plan or live query stats. So for those queries that never finishes, now you can actually watch them. You can get the actual execution plan. So of course, performance is not good. You see the database is not working, website is down, and it could be temporary performance problem, right? Oh, could be because you did upgrade, database upgrade. So there's could be lots of possibilities, but generally the common reaction from your user probably just saying database is slow. It's very hard to figure out what's going on when somebody just said database is slow. The query store, you can actually do all these, find and fix the plan regressions. We have instrumentation and we have user interface for you to easily see them graphically, right? It's, I think, better just to show you. And it can de-risk, can identify the top resource consumers, and the de-risk server upgrade. Because between, versions, we don't just change storage, we do work with Query Optimizer. And also it's super useful to analyze your query patterns. Help you next time you buy new hardware, right? And help you plan better. If you know your workload is doing mostly scan, mostly seeks, and in which table, and you can do better planning with that kind of information. So live query stats, and fairly obvious thing is if you have long-running query, you want to know the actual execution plan. You will never get it because the query never finishes. And the whole problem originated is because the estimated plan is inaccurate, right? So bit catch-22, and need to do a lot of guessing. Now you can actually get your estimated plan, and when it runs, if it runs longer than you expected, you can actually look at the actual execution plan in flight to see if the estimation is completely off base, right?
Right. So
this is DMV we added. Actually, this is in 2014 as well, but we didn't have UI for it. And called the DM exact query profile and profiles. This integrated, before you have to do a set statistic profile and CPU and to gather everything about query plan, right? But the query have to finish. So we integrated the code to actually report back the actual estimation and the counter real time. So let me show you how that works. If you actually install 2016 now, this is all there. So let me use my favorite database, AdventureWorks. Trace flag, make sure it all works. So in the management studio, you see this new icon called live query statistics. See, this is actual plan, right? This is estimated plan.
Right.
Now you have this new thing with the yellow arrow in there. So let me click on there and run this. We know this query will run for a while, right? See, it's like select a bunch of stuff and doing a lot of random joins. So this query will run for a while. So see, as you can see, this is actual execution plan. This is little animation going on, but the important thing is you see this, the sort, percentage done, and the actual seconds and the actual rows are being updated. Number of rows, estimated rows, and the actual rows, right?
Very nice.
Yeah. So you can script this, and this can be actually run from a central location to through the DMVs. I love this demo. So easy and so cool.
Yeah.
It took us to release to get everything completed.
Mm-hmm.
One minute now. All right, let me just kill it. I think I made my point. 38% done.
Oh.
Okay, let me show you Query Store. I think Query Store is really cool. All right, Query Store. Let me show you first thing about Query Store. You can use the Query Store to do upgrade. So you can upgrade to, let me show you the property. So, you know, when you upgrade your database, right, you can set compile level. We support back to 1, 2, 3. We support 3 versions back of compile level. Compile level will guarantee the behavior of query optimizer is the same as the previous version, and so you have a lot higher chance to get a previous old query plan. As long as your data doesn't change, you update the statistics. Oops, sorry. Where did it go? Okay. And so the with what's new, you will see this. Here's a tab, Query Store node that wasn't there before, and by default, it's actually when you first install, it'll be like this. It's turned off. See if I click it, okay. Then this, if I refresh, you will see that the Query Store node went away, right? It's turned off. So then if you turn off, there's no overhead or don't collecting anything. And you can turn on, there's 2 modes, read-write or read-only. One read-only is you collected enough query plan, you don't want to take up space, right? You don't want to delete anything, so turn in read-only mode. And you can change the data flush intervals and statistics collection intervals and everything, right? Statistics is hopefully doesn't change as much, but if you have very high volume, you might want to do it sooner. And so there's a lot of knobs, and you can purge it, of course. Don't want it anymore, and it's back there, right? So the coolest thing about Query Store, you see all these default views, and let me pick this. Top resource consumer. If you go drop down, you can see, you know, when you remember all these scripts you use to troubleshooting your queries, right? The CPU time and the duration of your queries. You run the execution count to find out which query worth most of your time, right? If the query takes average 10 seconds being run 10,000 times, you better tweak that one, right? And if it's logical reads, lots of logical reads and logical writes, and it depends on if you have memory pressure or not, all that. So this is all here, just simply by drop down, it will change the view. Very simple. And everything really just a click. And you can configure different views, and it will show different plans. If you query, get multiple plans, right, which happens. And here, say, I want to look at execution count first. There's no query yet. And let's just do duration, see who's running the longest. Okay, I get this little app as running regression queries. So in this query, and every about 10, 15 executions, we get a hit a bad plan. And just because the way running the loops and pick up the rows. Let me do a refresh. Okay, you can see this one based on duration. I have this one query. You can see everything is here, right? Query plan, same as before, all integrated in one spot. You get 2 plans, 1, 2. Obviously, plan 1 is a lot better and running a lot faster, and the plan 2. We don't really like it. It takes way longer, right? So what you can do is really simple. Select this, and by a click of button, I'm forcing the plan. So from now on, all the execution will not recompile anymore. It's basically just going to go pick plan 1 from the cache store. And with a click of button, you can enforce it. And this is plan force because it's picking out from query store, so it will survive a rebuild, restart, and shutdowns because we persist that in the disk. And you can also, if you want, you can compare the plans and see what's the difference. Apparently, the table is small, the scan actually goes a lot faster. And let's refresh, just make sure, see, there's a plan 2 is not there anymore. Right? And simple thing, if you don't want to, just enforce it. So that's query store. I think query store and the live stats itself to worth the money to upgrade.
That's true.
I hope you think the same. All right, that's my little demo on the query store. Oh, we're already into 10 minutes. Let me see. Okay, I'll probably not be able to run through everything. Okay, quick summary and a couple of things I do want to call out was mission critical. We have always encrypted, I talked about, and we have row-level security now, both filtering and blocking. We also have dynamic data masking. And this is actually the counterparts of always encrypted. In this case, if you want to share your data results or analytics data, right, with your partners, or with dev test, for some reason they don't have permission to see everything, for example, salary, right? You can actually declare a security officer role can declare masking function per column, per row. And so they will have the right data schema and distribution, and depends on how you define your function, and the data will be obfuscated as the results on the client side. And with always encrypted, we will support DTC and the distributed transaction. We added round-robin load balancing for the replicas, and we will support, most importantly, it's not on the list, it's coming, and probably by the time we release. We support the domainless always on. Basically, right now you create always on based on the cluster. You have to have domain account to create that Windows cluster, and you put AG on it, right? Always on. And with 2016, and you don't need a domain account anymore. You can create a domain class, create a cluster without domain account. That's lots of the enterprise customers asking for that. Also, you can create a cascading always on group. Basically, you can create 2 separate AGs, right? Always on group in 2 separate data centers. And you can designate one, say, in the remote data center, and the primary as the forwarder. So you can create a hierarchical always on group. It's difficult to say without a diagram, and but anyway, if you have that need, you know what I'm talking about. Maybe we can have a drill down session next time.
Sure.
And the second thing is we're going to do direct seeding, because right now the secondary, if you want another secondary, you have to do a restore and do restore database and do back up the logs and restore the log to synchronize and establish partnership. It's just lots of work, right? And we have both of these features in SQL Azure already, so we're just going to move it into the box as well. So you can basically pointing to a server says, this is going to be my secondary, start direct seeding. Then we're going to seed that secondary for you in the background. And when the data is finished, restored and synchronize the log, and it'll become active secondary. I think we're running out of time. Derek, how about I can do the rest next time?
Sure. Okay.
Because it's already 10 minutes to.
Yeah, I think we can ask us some time for the Q&A for the audience. I already collect some question for you actually. So someone asked if you can call out most impressive features, consider skip the 2014 and upgrade to 2016. What are they?
Yeah. Actually, this question shows that comes up a lot. Actually, upgrade itself, right? It's a fairly straightforward thing. The most painful thing actually is on your side, you need to do planning. Skip 2014 or 2016 doesn't save you much work at all.
Now,
you still have to do the upgrade work, right?
Yeah, his point is right now if I consider to upgrade from the 2008 R2, from 2008 R2 to 2014 or to 2016, what's the most reason can convince his manager to skip 14 directly to the 16?
Oh, okay.
Mm-hmm.
Well, I wish I have a simple answer. I don't. It really depends on what is your pain point right now. I would have the conversation with the manager says, doesn't matter upgrade to 2014 or 2016, what does the manager, he or she, looking for in a database, right, for your particular application or systems.
Yeah.
Performance, availability, or some cool features, JSON, temporal, always encrypted,
Right.
If a certain feature absolutely doesn't exist in 2014 and it's critical to your manager to write that check, right? That would be it.
Yeah, that makes sense. Yeah, that makes sense.
Okay.
And the other question is I think you mentioned one time to me, and I asked a question same time for my local Microsoft. The guy say, the language what's the status right now for the 2016 to integrate language R?
Okay, good question. So we got the code checked in the main branch now, and so means the core extensibility work is fairly stable. You will be able to get the build to test by CTP3. That should be SQL Pass time. You talked about SQL Pass earlier, right, in Seattle. So that's our target date by the SQL Pass week. We should have a build for you.
Okay. We have another question talk about the encryption, always encryption. So let's say we have the asset, the social security number in the source system. And when you migrate the patient information from the source system to DWH, you will copy as is the encrypted data, or you will decrypt them, copy to the DWH, then encrypt them again. Which way to go?
To which one? To data warehouse?
Yes.
So you can copy it as is. The key is that you need to have that the application connect to that data warehouse and need to have the master key. Otherwise, the data warehouse application won't be able to read the data.
Yeah, gotcha. So you think the master key is not the database master key?
Right. Yeah. The key is on the application side.
Okay, I see. Cool.
So if your data warehouse and your operational data store have a different application, it probably won't work. You need to encrypt it. Yeah.
Gotcha. Okay. Another question. Actually, I think her question is how the system backup the data in OLTP in memory.
Just like the same way as the regular database backup. We integrated everything. So what happens is with in-memory OLTP, we write the checkpoint files on disk. And so actual backup will actually take the Hackathon or in-memory OLTP file group, which contain all these checkpoint files, back those ones up. And when you restore on the secondary on another machine, Hackathon know that's a Hackathon checkpoint files, and we're starting redo or load those checkpoint files back into memory. Of course, the longer, the bigger the in-memory database is, the longer it will take to load everything. So it will help if you have faster I/O storage to streaming data back in memory. With Hackathon, the challenge is until all the data loaded back in memory, you can't use it, right? The data has to be in memory. Yeah.
Okay. Let's see any question we have here. All right, I think most of us actually right here is the BI developers. We do care about, we have a lot of features before like data tracking and the CDC, capture data change, Right now, I heard about a tempo. What is tempo? Can you show us a little bit about tempo? Tempo table.
I think we have a little time. Let me show you I have a little demo. I hope it still works. Restore, my temporal time travel. Okay. What the temporal is, so temporal is you actually only insert data and you want to keep track of history. For example, you not only want to know the data state, right? Like, for example, in this case, we have like an org chart of our European office, engineering offices, right? You see there's a Belgrade and London and what have you. If you want to know the state of, say, back in 2015, let's say January, okay, 2014 January, July, April, and right. This happens, right? You want to know what happens back in time a year ago, a year and a half ago, right? So you get a snapshot. Now we see this is what the office looked like in Europe back in 2014. And if you want to actually to implement this today in your application, in your own user schema, you actually have to date everything. So every record, update, deleted, so-called self-delete, insert, update, you have to have expiration date, effective date, and date and time, of course, right? And for every row. And when you do the query on that table, you always have to have the predicates of the actual date and time you want to look at. So the query is kind of expensive, convoluted, because I implemented this text data warehouse. And with this, you can really easy to do, right? So you want to compare, see what changed in the August, and this is just little app. But in real life, the most popular scenario is data auditing. So, for example, you want to do text, right? You want to see what changed, and what changed, how they changed it, when changed it. So this is all pretty interesting. And if you have to do it yourself, actually, it's a lot of work. So what we do is we did this for you, and I think I have the query I can show you. This one. So we actually track this if you enable the table as a temporal, right? And we actually do it for you behind the scene in the database. So you don't have to actually add all these user columns specifically, so you only be able, so just enable you to go back in time. And we added this keyword as of, right? Mm-hmm. And what this does is it's actually allow you to specify a time, so you can snapshot back in history. And this way, it's integrated with Query Optimizer. You don't have to go out of your way to do it very convolutedly in user query. And if you don't actually specify a as of date, it will be just current date. And for now, we're going to support just system time. This is defined in the ANSI SQL 2011 standard. We implemented the spec, basically.
Very cool.
So the comparison, just this simple query, it'll do the comparison. That's what this little app is using. Right. And without if you look at the table itself, it doesn't, we just create a view. Yeah, you don't have to do everything so complicated. And the history table can be stretched with this to Azure using a stretch database, which I didn't get around to talk about.
Very cool.
Okay, thank you.
Yeah. All right， 我们再看一下，还有没有同学有问题的？非常好的机会问一下Lindsay。当然我知道SQL 26还有很多好的 feature 啊，还有很多好的 feature， 因为我看过一次完整的版本。我们有机会请 Lindsay 再回来给我们讲下一期。当然就现在我们讲的，你看看大家有没有什么问题，或者你关心的什么问题？看一下问题。
Oh, you recorded the session.
Yes, I recorded the session.
So everybody see my desktop, everything. Okay. Is it this? Are you sharing this public? It's not public, right?
It's not public. It's only shared by the past community. So.
Oh, okay. Okay. Cool. Thank you.
嗯哼。Alright， 看上去没有什么其他的问题，所以非常感谢你非常精彩的给我们分享那个 SQL Server 2016的一些 new feature 我个人觉得非常的 impressive 这个新的版本下一次有机会我们再请你来讲一次其他的 new feature。我知道其实2016的 new feature 有很多，你今天可能只 cover 了30%或者25%非常感谢你的时间，谢谢。
Yeah， 谢谢大家。OK，拜。
Alright。